through our office at McGill, we try to shine light into the dark crevices of the world of pseudoscience. And I started doing that a long time ago because I suspect, as many of you, when I was young, I got a chemistry set. I played with it. And in those days, chemistry sets still had chemicals. And when I got older and started teaching, and I had a daughter, I thought that her education should begin. So I asked her to go to the school library and get a book on science. And she came home with this epic, with all kinds of riddles in there. Why does the mad scientist like sales? Because he's 50% off himself. Or how many drops of poison can the mad scientist put into an empty test tube? How many? 1, because after that it's no longer empty. Not so bad. But anyway, I mean, this alerted me to the importance of going out and talking to the public about chemistry and about what it can do and about setting the record straight, making sure that people understand that chemicals are not to be feared, neither are they to be worshipped, but indeed they are to be understood. And if you understand them, then you won't be taken in by nonsense such as this. And I think there's a good chance you won't have irrational fears, and confusion will turn to wisdom. But all it requires is a little bit of chemical action. And then you can look at the literature and interpret it properly. Oh, there are headlines galore. This one, of course, is not a it's not a very alluring one for men. But it turns out that it actually is based on a legitimate study done in Italy, where there's a region that is quite contaminated with perfluorocompounds because of a chemical processing plant there. And they compared teenagers who were living in that area to teenagers who were living elsewhere and found that indeed they had higher levels of perfluoroalkyl substances in their bloodstream, and also measured their penis length. And it turned out that the exposed group had somewhat longer shorter than the control group. And it turns out that when you look at the margin of error, these numbers are basically the same. So, and of course, the study said absolutely nothing about kitchens or pans. So you can quite safely go out and cook in your nonstick fry pans, and you really don't have to worry about any consequences. And I suspect that Paula Deen cooks in fry pans, non-stick ones, but she will never put margarine in there because to her, margarine is one molecule away from eating plastic. And I suppose she's very happy consuming lots of butter because she stays away from margarine. But of course, butter and margarine are just triglycerides. They're fats. And if you look at the molecular structure, they have absolutely nothing to do with polymers, the plastics. Those are long-chain molecules. This is total nonsense. If you want to make an argument for something being one molecule away from something else, I mean, you could say that ethylene is one molecule away from ethanol, but it makes no sense whatsoever. It's the final chemical composition that matters, not where something came from. There are people, of course, who don't know that. Our good friend, the food babe, thinks that we should stay away from vanilla ice cream because it is made from beaver butts. Well, where does she get the chemistry so wrong? There's a gland on the back of the beaver, nothing to do with its butt, that produces a set of chemicals that, in theory, in the lab, can be converted to vanillin. Of course, nobody does that. This would not be economical to catch beavers to make ice cream. The way that it is done chemically is to take wood, extract the lignin from the wood, and that, by a series of reactions, can be converted into vanillin. The food babe, of course, doesn't realize this, and I thought she needed some education, so I did send her a book. But believe it or not, I did not get a thank you for this. I also would have sent one to Dr. Edward Fujimoto if I could have found him. I don't know if he actually exists except on the internet, because there he is often quoted that combination of high heat and plastics releases carcinogenic dioxins. Well, dioxin, this particular one, the tetrachlorodibenzodioxin, indeed is nasty stuff. We don't want any contact with it. But it does not come out of your plastic in the microwave oven. His contention is that if you use plastics in the microwave oven and heat it up, it will release dioxin. Where does this come from? Because if you take PVC, polyvinyl chloride, and you put that in an incinerator, it will indeed release dioxins. However, the vessels that we use in microwave ovens are made of polyethylene or polypropylene. They are not made of polyvinyl chloride. They do not contain chlorine. And since they don't contain chlorine, it is impossible to produce the dioxin. Cannot be done. But even if you were to take PVC and put it in your microwave oven, nothing would happen because your microwave oven is not an incinerator. So there would be no issue about this. But where dioxins can indeed be found, or at least were found, was in Agent Orange. Agent Orange was so called because it was shipped to Vietnam in drums that had an orange band on them. And it was a mixture of 2,4-D and 2,4,5-T. These are the herbicides. And of course, it was used as a defoliant. The problem was that because of the manufacturing process, 2,4,5-T, that was the problematic compound, indeed could form a byproduct, and that was dioxin. Dioxin is nasty. There's no question that it leads to malformations. It is indeed a carcinogen. But recently you may have heard about it in another context. Supposedly, Monsanto is killing off the population with the so-called Agent Orange corn. Well, where does this idea come from? There's corn that has been genetically modified to resist 2,4-D, so that you can spray the field with 2,4-D and not kill the crop and kill the weeds. 2,4-D was indeed present in Agent Orange, but it was not the problem. 2,4-D did not form tetrachlorodibenzodioxin. There is none of this possible in the 2,4-D. And yet, people are worried about Agent Orange corn because of all the nonsensical activism out there. So I've long enjoyed talking about chemistry to the public, but there was actually one pivotal moment that brought home to me how important this was. And this was a few years ago, about 20 years ago, I would say, when I get a phone call about 10 o'clock in the morning from a friend of mine, and he says, "Hey, you have to turn on Deanie Petty." Well, I didn't know who Deanie Petty was or how I was to turn her on at 10 o'clock in the morning. Well, I've quickly found out that she was the host of a television program, and she was on there chatting with a guest who said, if you can't pronounce the words a chemical, and I don't know how many people want to be eating chemicals. And then came the stunning revelation of who this lady was. She was Carolyn Dean, MD, a real physician, called herself a nutritional consultant. She went on to say that when you're talking about chemicals, even moderate use is too much. Well, that was too much for me, and I decided to target her. And I started to send letters to her explaining her folly. She was also into homeopathy, so I explained how non-existent molecules cannot cure existing diseases. And eventually I had the chance to go on the Deanie Petty show myself and to voice this opinion. But by that time, Dr. Dean had left Canada. She had her license removed for various malfeasances. And she ended up in Hawaii. And she is now writing books like Death of Modern Medicine. And she believes that magnesium is the answer to all of life's problems. Because everyone is magnesium deficient, and it will solve absolutely everything. Diabetes, osteoporosis, depression, generalized inflammation, all of these are due to lack of magnesium. Well, talking about magnesium, it has another interesting chemical possibility. You may have heard of hydrogen water or hydrogenated water. you can buy this little device, and they will tell you in the blurb that hydrogen is a powerful antioxidant, which is actually true. Hydrogen is an antioxidant. You know, hydrogen reacts with oxygen to give you water, so it is, in fact, an antioxidant. What you have in this little stick is magnesium. And the idea is that you put this stick into water, and the magnesium will react with the water, produce hydrogen. Well, I tried it. Didn't look like anything was coming out of it. But I thought, maybe this needs a bit further exploration, because there are other devices that can actually put hydrogen into water more effectively. So I sent for one of these. I splurged a couple $100 because I like to splurge on quackery. And anyway, it turned out that this was really an electrolysis device. And you plugged it in, and this time you actually would see bubbles forming. And there was the hydrogen. Now, the argument is that hydrogen is an antioxidant, and you've heard all these stories about antioxidants being miraculous, of course, which is mostly nonsense. But anyway, here's the chemical fact. Hydrogen is not very soluble in water. So when water is indeed saturated with hydrogen, which you can only do under pressure, not in a device like I just showed you, you get about 1.6 milligrams per liter. But that hydrogen will almost immediately evaporate out of the water because it is insoluble. But anyway, I bought the device and I hydrogenated it and I tried it. And it didn't do anything except give me a bitter aftertaste for the science involved here. And I think that I would have an idea for a better packaging format for this. I think what this really should contain is that. But believe it or not, if you look at the scientific literature, you will find papers singing the praises of hydrogenated water. But of course, as you know, you will find papers about anything, because we have 5 research papers coming at us every single minute of every day, 365 days a year. Many of them are good, many bad, most mediocre. But you can find a paper to back up absolutely anything. You know that you can find publications to back up homeopathy. So it's not surprising that you find some about hydrogenated water. But there are others out there who have different ideas about how to revitalize your water, not just adding hydrogen. You can use the Danish water revitalizer, and they tell you that the real problem with our water supply is that water cruises through pipes. And the real problem is that the pipes are not always straight. Sometimes the pipes are bent. And what happens is that these water molecules, which are happily cruising your pipes, all of a sudden come to a bend and smash into it, and then bond angle is altered. So you have to correct this. And of course, they can sell you the means by which to do so. This is it. You can screw this onto your tap or onto your shower. Obviously, this is total folly, but it's harmless folly. But they also sell you this device, which is portrayed as a water filter system. The Vortex water revitalizer is based upon evolutionary concept in water treatment. It performs far beyond other filtration systems. So people might believe that you are actually getting some better quality water out of this, which is just total nonsense. But nonsense, as you know, sells. Sometimes it sells for a lot of money, $3,000 to $4,000 for your water alkalizers. But of course, it comes with science. They will refer you back to Dr. Otto Warburg. They tell you that he was a double Nobel Prize winner, which is not true. They can't even get that right. He won 1 Nobel Prize. And indeed, he did win a Nobel Prize for looking at what is going on in cancer cells. And it turns out that cancer cells do tend to be acidic. That's because they rely a lot on glucose as a form of energy, more than normal cells. And eventually the glucose runs out and you form lactic acid. I mean, this is very similar to what happens when you're running. It has absolutely nothing to do with acidifying the body. It is true that there's a higher level of acidity in cancer cells, but it is because those cells are cancerous. They don't become cancerous because of any acidity. But the people who sell the alkaline water will tell you that this will cure everything, not only cancer, but all of these other conditions, because the body has to maintain a proper pH level. Of course, if this were true, you could use sodium bicarbonate to get a glass of alkaline water. You wouldn't have to spend $4,000 on a water alkalizing machine. But then, of course, there are people who push this further and tell you that we should be eating an alkaline diet. Getting things right for the wrong reason. An alkaline diet, the way they define it, is mostly fruits and vegetables, which is great, but nothing to do with the alkalinity. But you will read all kinds of articles about alkaline foods versus acidic foods. And this comes from some icons of science, like Tom Brady. You may have seen Tom's book, in which he talks about his success. Now, I'm not going to argue about his success. Tom Brady is maybe the greatest quarterback who ever lived. And he is a great physical specimen. He exercises a lot, and he probably has a good diet. But it has nothing to do with alkalinity. I mean, he's really dropped the ball on that one. But that ball was picked up by Anthony William, the medical medium. Oh, what an amazing character this is. And he's got a gigantic following on the internet. His books are on the New York Times bestseller list constantly. His latest one is about celery juice, which is the cure for absolutely everything. Your taste buds will rebel when you try this. And what he doesn't tell you is that celery is extremely high in nitrates. And there's a lot of concern about nitrates because in the body they form nitrites, and nitrites can form nitrosamines, which are known carcinogens. This is why hot dog producers now are adding celery juice instead of nitrite to the hot dog, because people are scared of nitrites, and they think celery juice, that's natural, that's okay, but celery juice is very high in nitrites, and your body doesn't care if the nitrites come from a chemical plant or from celery. But where does this medical medium get this stunning advice? He gets it from the spirit world. He has a direct contact to some spirit who gives advice, medical advice. At the very least, this guy who is on the radio, he has a radio show, should be taken to task for practicing medicine without a license, because he is giving serious medical advice for serious medical problems. It always comes down to celery juice, but it's stunning that this should be allowed. This is something that just makes your head spin. And talking about making your head spin, you may have heard of alpha spin. This is a fascinating device because it cures absolutely everything. It's $300, but I like to spend on quackery. So I bought it. And here it is, in living color. It looks like a glass coaster. It's an expensive glass coaster. What do you do with it? Well, you place it on your body because it is going to do amazing things. Just look at the amazing things that it can do. It can vitalize your food. Obviously, it aligns your chakras and everything else. It will neutralize electromagnetic radiation. That's the big boogeyman now, because we're all exposed to this. But as I found out, in order to really be secure that you're not being inundated with this dangerous radiation, one of these is not enough. You need 4, because you need to set up a quantum pyramid inside of your house, and that will then solve the problem. That was $300. But for $100, which is a bargain, you can get the Polaroid disc. The Polaroid disc has 2 sides. You flip it around, that's what it looks like. And when you look at it from the side, it's very thin. Here it is. Of course, it's extremely thin on science. But here's all the verbiage that comes with it. Again, you see that it's good for absolutely everything. So your chakras, of course, you can purify your fruits and your vegetables. You put it under your plants. It will make the plant grow. They refer to Tesla in this, in some incomprehensible fashion. But they make a very good game out of it. When you read this, and if you don't know any science, it kind of sounds somewhat believable. I tried it, of course. I wanted to see if it would realign my chakras, and didn't do anything. Gave me a bit of headache. That's about all, because of the faulty science in there. But it's one thing to talk about all of this silliness, and many previous speakers here have alerted you to that. The question that comes up, though, is whether or not we are in any way successful in trying to combat this. What can we do to get around this silliness? And sometimes we do have successes. And this is an interesting story. A few years ago, two ladies came to me, and they had just gotten back from Poland. They had been there on a trip, and they had learned about a new wonder product that was capable of curing virtually every disease. It was called PMAT. And they came to me because they wanted my opinion on this. They legitimately didn't understand the words that came with it. I mean, I had trouble understanding it too. According to the inventor of PMAT, the action of this product is based on the energetic effect of its geometrical configuration. Neo-energy, a term proposed by Dr. whatever, means the action of a shape on matter. It should be emphasized that in spite of a great number of research, the nature of this phenomenon could not be explained in terms of physics. The energy emitted has not yet been measured by any conventional method, but it is scientifically accepted because of the neo-energy and the radiesthetic colors. Radiesthetic color is conventional notion meaning that specific color corresponds to a specific wavelength. Well, that much is true. A specific color does correspond to a specific wavelength. Well, what was this wonder product? What was this PMAT? Here it is. It is a square piece of cotton with specific arrangement of red dots. And that is the key. Here it is. Here is PMAT. But it is exactly where those dots are. That's the magic in this. For that magic, you pay $80. $80. Now, what do you do with it? Well, you put it under your back, under the sheet, when you are sleeping. Well, of course, this sounded kind of hokey to me, but I thought that here was an opportunity to educate. So I said to these ladies, what we do in science, when we have a situation like this, we design an experiment, we design what we call a randomized double-blind study, where we subject one population to whatever we're testing, another to a control, and see what happens. And I kind of explained this to them, and they were okay with it. And I gave a monthly lecture in Montreal to senior citizens. I've been doing that for about 35 years, and it's a very fulfilling thing because they're generally interested in science, and you get some points across to them. But these are people, of course, who suffer from arthritis and have all kinds of aches and pains, etc. So I thought this was a good population to try to organize a randomized trial. And I suggested this to them, and they were willing. I said, we have something here that we would like to test. I'd like to help. Now, of course, we needed some sort of control for this. So how do you get a control for a PMAT? To me, it was obvious. You get a blank cotton sheet made of exactly the same way without the red dots, because the red dots, of course, are supposed to deliver the magic. But the people who were trying it must not know whether they are sleeping on this or on the blank. So I thought we needed to put it into a cotton bag like that, which would be numbered, and only some objective person who had nothing to do with us would know what the code was. We contacted the company in Poland, telling them that we were going to do this. Believe it or not, they willingly designed the envelope for us. I can't explain that, but I guess it would have been too much for them to argue that these red dots could concentrate the energy of the universe into a person, but they could not traverse a cotton envelope. So anyway, we did this. Divided the population into two groups, and they were given, for 2 weeks, forms to fill out. Every morning, they would put down how they slept, whether they had aches, pains, or whatever, for 2 weeks. They didn't know what was going to happen. They just filled out these forms for 2 weeks. Then we gave them the PMAT. Half of them got the PMAT, half of them got the control. After 4 weeks, we switched. So we had 10 weeks of data. 2 weeks with nothing, 2 weeks with PMAT, 2 weeks with the control. What was the result? Well, as you would guess, the result was there was absolutely no difference between the two groups. But there was a tremendous difference between the starting time and the first 2 weeks, end of the first 2 weeks. Why? Because they thought that there was something that was going on. They thought that we were testing something, right? And because of the way the questions were designed, it was clear that, this was something to do with health. So I'm talking about the first 2 weeks after we, initiated the study. It was a very interesting finding, especially because when you looked at the forms, remember these were senior citizens, and boy, some of the activity levels at night among those senior citizens was quite surprising. But it was not enhanced by PMAT. It was good to start with. So how do we explain this? That there was this tremendous difference between starting the PMAT and what had been going on before. I think we all know what this is due to. It is the very strong placebo effect. And the placebo effect is extremely powerful. It is so powerful that it even works when you know that it's a placebo. One of my colleagues at McGill, Dr. Amir Raz, has done a great deal of research on this. And it is really amazing that when people are told that it is a placebo, it still works. We've not been able to explain why that is. I have a theory about that. I think it is because they think that you're carrying out a study and that you're giving them something that is really effective, but you're telling them that it's only a placebo. Anyway, that's just my theory. Anyway, after all of this adventure with PMAT, I went home and I realized that I had been doing myself a great deal of good anyway because of the sheet that I had been sleeping on. So what is the moral of all of this? I push chemistry. We do that through our office because I think chemistry is the science that ties the other sciences together. If you have a good understanding of what molecules are and what they can and cannot do, you have a pretty good feel for what can and cannot happen. And we try, of course, to intervene in various ways. And today at noon, you will hear from my colleague, Jonathan Jarry, about some of the successes. Because, it's one thing to fume at all of the nonsense out there, but it's something else to try to do some good. And I think Jonathan will very, very capably tell you about some of the things that we can do. And I think it's important to understand chemistry and science in particular, so that when you're confronted by some novelty, like the John Ellis water machine that you can buy on the internet, and it comes with all kinds of explanations, telling you that if you just alter the bond angle in the H2O molecule, you are going to do a great deal of good, because if that bond angle gets constricted, that's where disease starts. So, I think with a little background in chemistry, which we can, I think, deliver even to people who have no knowledge of chemistry at all, it's not all that difficult. I think realize that when you see something like this is quackery that needs to be overturned. And sometimes you wonder, how successful you are. Well, I just came out with a book last week. It's called A Grain of Salt. Came out a bit too late, it's not available here. But it did make the bestseller list the very first week, which I was very happy with. But, as you know, in science, there's always a but. I did make the listed at number 9, but there is at number 5, Anthony William with his celery juice. And a number of others, as you can see on that list, fall into the rather questionable variety. Stephen Gundry's book on the plant paradox, where he thinks that lectins are the absolute poison, is also total nonsense. So I think the battle has to go on. We have to put the spotlight on separating nonsense from the sense. And that is exactly what we try to do. And if you go to our website, you can sign up for our weekly newsletter that gets delivered to your inbox every Saturday morning at 6 a.m. with a host of what we think are informative, entertaining pieces. So I hope that I've been able here this morning to put chemistry in the limelight for you and to stimulate some action when it comes to chemistry. And if any of you are interested in the break, I will have the PMAT, I will have this disc, and I will have the spinner, and I will cure every disease that you have. Thank you.
Thanks for watching. If you liked this video, be sure to give it a thumbs up and share it with your friends. Don't forget to subscribe to the channel and ring that bell to be notified about new videos. You can follow us on social media, and if you really love what we do, consider supporting us with a donation. Links to all that good stuff is in the description below.